A rope pulls a 20 kilogram sled at 40 degrees above the horizon with a magnitude of 10 newtons. A friction of 2 newtons is acting on the sled. What is the acceleration of the sled? So first we're going to want to visualize what's going on in this problem. So we're going to draw a graph. And in our lovely graph, we're going to identify all of our forces. And so first, let's start off with our applied force. So we know, since this is a vector, we're going to want to deal with our x's and our y forces of the applied. And so we are going to put 10 cosine 40, because that's our theta, and then 10 sine 40, because that's our theta. And then this is our hypotenuse, which is our magnitude. And F sub g, that is our weight / gravity. And so it's our mass times negative 9.81 meters per second. And then this is our friction force. And it's negative 2 newtons because we're going in that direction, the negative direction. And then our normal force remains our normal force because we have no information about it. And so now we're going to write out our problem, our givens over there. So now that we wrote out our givens, we're going to actually apply them to our charts. So we have our forces divided into our x's and our forces divided into our y's. So our F applied, the force applied of x is 10 cosine 40. And then our friction is negative 2n, which is also right there. And the force net of all of these two is 5.660 newtons. And then our y's, our weight is negative 196.2. Our F applied is 10 sine 40. And our normal force is our normal force because we don't know our normal force. And we're going to set all this to 0. However, we're not going to use our y forces because we can solve this problem by using Newton's second law with just the x's. And so the force net of all the x's is equal to mass times acceleration sub x. So we can plug in our givens. 5.660 newtons is equal to 20 kilograms times ax. After dividing by 20 kilograms of both sides, we get 0.283 kilograms times meters per second squared is equal to acceleration.